And welcome. In today's video, I'd like us to talk about matrices. What are matrices? Matrices are a rectangular array of numbers enclosed by square brackets. Okay, so matrices, they basically have entries. Let's see an example of what a matrix is like. Let's suppose A is a matrix with entries 1, 2, -1, 3. Okay, so if A is a matrix, what we have to understand is that it consists of rows and columns. Consists of rows and columns, where rows can be identified horizontally and columns are identified vertical. What this simply means is that on A, when we go horizontally like this, we're gonna see that we have row 1 there and then row 2 there. Okay, then when we go vertically like that, we're gonna see that we have column 1 there and then column 2 there. Okay, so rows and columns gives us in a matrix what we call an order. Okay, so an order of matrix A is given by row times columns. Okay, so we agreed that we have 2 rows and 2 columns. That implies A is a 2 by 2 matrix. Okay, so now what we see here is that the number of rows and the number of columns are equal. So when the number of rows and number of columns are the same in a matrix, it implies that that matrix is what we call a square matrix. It's a square matrix. So A is a square matrix. But otherwise, if the number of rows and columns are not equal, then that can no longer be a square matrix. Okay. So let's investigate more of matrix A and see what is happening. So let's suppose we want the entry A12. So the entry A12, what this simply means is that the number 1 represent row and this number 2 represent column. Okay, so on matrix A, we want to find an entry on row 1 and column 2. This is what this simply means. Okay, so we're going to go to row 1. This is our row 1 and column 2. So the intersection of row 1 and column 2, we see that it is this number here, 2. So A12 is basically equal to 2. Okay, so now let us find another entry, A11. So A11, you can go ahead and try it yourself. Okay, but we see that the rows, it's in row 1 and column 1. So row 1 is this one, then column 1. So the intersection of row 1 and column 1, we find that it is that number there, which is 1. Okay, so that is basically how we identify entries. Okay, so let's see if you get what is going on. Let's suppose we have another matrix B with entries 1, -3, -4, 6, 7, -8, like that. Okay, the first thing that you will want to identify is the order. Okay, remember that the order is given by row times column. So what is the order of matrix B? It's basically we have 2 rows like that horizontally, and we have 1, 2, 3 columns. Okay, so since the order is given by row times column, it basically implies that the order of matrix B is 2 by 3. Okay, so can we say that B is a square matrix? No, because the number of rows is not equal to the number of columns. So B is not a square matrix. Okay, so let's identify the entries B13, B22, and B21. Yeah, let's identify what are those entries. So the entries B13, we're going to row 1 column 3. So row 1 is this one, column 3 is that one. So the intersection we see is 4. So B13 is basically equal to -4, -4. Then B22, we're going to row 2 column 2. So in the intersection we see that is 7 right there. So B22 is equal to 7. Then B12, we're going to row 2 column 1. So we're basically on this number. So B21 is 6. Okay, so that is basically what is happening. So let us find out what is happening with matrices more. Let's suppose we have matrix A being equal to matrix B. Okay, So for matrix A to be equal to matrix B, what this simply means is that all the entries in matrix A should be the same as all the entries in matrix B. Okay, so let's suppose I'll use variables. Let's suppose matrix A was identified by A, B, C, D as the entries, and matrix B was identified by E, F, G, H as the entries. So for this statement to hold, then it implies that the entries in A, the corresponding entries in A should be equal to the corresponding entries in B. So if we are saying the corresponding entries should be the same, that implies A should be equal to E. So you see that A11 is equal to B11, okay? And it also implies that B should be equal to F, okay? So if B should be equal to F, and what else? C should be equal to G, C should be equal to G, and also D should be equal to H, like that. So the corresponding entries must be equal, okay? So we can solve a problem of that nature where we are given two matrices where the other one has unknowns, then we can solve the unknowns. Let's see an example of such a problem. Okay, let's suppose you have 2a plus b on the first entry, then 3b, then b plus c, and 5d plus 1, and it is equal to 3 minus 3, 2, 1. Okay, so from the explanation that I was making from here, we see that we can apply that knowledge on this type of a problem. Okay, so what can we say? We can say that, oh, okay, so since the corresponding entries must be the same, we see that 2a plus b must be equal to 3. So we're going to write that down. 2a plus b must be equal to 3. And we see that 3b must be equal to 3b must be equal to minus 3, like that. And we also see that b plus c must be equal to 2. Okay, and what else? 5d plus 1 must be equal to 1, like that. Okay, so we can solve these unknowns. From this one we see, oh, this is one of the simplest to go with, so we can find b, or b is equal to minus 1. Divide both sides by 3, we find b is equal to minus 1. And also for this one, we see that they say 5d plus 1 equals 1. So when 1 goes to that other side, we get 0. Then this implies that d is basically equal to 0. Okay, so for this one, b plus c, since we know that b is minus 1, we can plug minus 1 there and then find what is the value of c. So that implies we can say that c is basically equal to 3. Okay, because if we plug minus 1 there and we take it to the other side, it's going to be 2 plus 1, which gives us 3. That is simple algebra. I'm sure everyone is comfortable with that. And now we see that on 2a plus b, since we know the value of b is minus 1, we can plug minus 1 there, then take it to the other side. Then it's going to give us 2a is basically equal to 4, and that implies that a equals 2. Okay, so now we know the value of a is 2, the value of b is minus 1, the value of c is 3, and the value of d is 0. So if we plug these values into this matrix, they have to give us the right hand side. Okay, so let's prove that is true. From left hand side, we see that the matrix that we have is something like, sorry about that, if we plug h2 there, we're gonna have 2 into 2, then b is minus 1, then 3 into minus 1. Let's close our matrix like that. Then minus 1 plus 3. Okay, minus 1 plus 3. And 5D, we said D is 0, so basically here we're gonna have 1. Okay, so that should be the same. It's gonna give us 2 by 2 minus 1. 2 by 2 is 4, then minus 1, that is actually 3. Then 3 times minus 1, that is negative 3. Then minus 1 plus 3, that is equal to 2. Then there we had 1. Then we see that the left hand side is therefore equal to the right hand side. Okay, so yeah, this is actually how you go about such problems. Okay, so this is the end of the video. In the next video, we'll be talking about addition of matrices, subtraction of matrices, and multiplication of them. Okay, thank you so much. Hit that subscribe button and the notification bell so you're notified next time I drop.